In this video, we're covering the example number 10 on our notes from section 2.5. So we want to find the derivative of y equals to x to the fourth plus 4 to the x over 3 plus 16x cubed. Number one thing that we want to do is identify the structure of this function. So overall structure is that we have a quotient, this function in the numerator divided by this function in the denominator. So at this point, I'd like you to pause the video and review that derivative rule or formula for a derivative of a quotient. And when you're ready, let's pick it up together. So now that you've reviewed that derivative of quotient, I'd like you to set up how we would compute the derivative here. So what does that look like? So the derivative, or y prime, would be low d high minus high d low over low low. So let's write all that out. So our denominator function is 3 plus 16x cubed times the derivative of the numerator function, x to the fourth plus 4x, minus the numerator function, x to the fourth plus 4x, times the denominator of the, times the derivative of the denominator, 3 plus 16x cubed, all over the denominator squared. So now we can just take a look and say, well, what derivatives do we even need to compute? Well, we need to compute the derivative of this function here and the derivative of this function here. So we could even do that in two chunks here. So derivative of x to the fourth plus 4x dx. So we see we just have a sum here. So we just compute the derivative of each term. Derivative of x to the fourth, we just use a power rule. So the 4 comes down. And then we have times x to the 4 minus 1 is 3. Plus derivative of 4 is now in the base and x is in the exponent. So we've seen those functions are what we call power functions here, or exponential functions rather. So when our base is a fixed constant and x is in our exponent, we have that the derivative is just that a to the x times ln of a. So for us, we had 4 to the x. So the derivative would be 4 to the x times ln of 4. And I'm just looking back at those basic rules for basic derivative rules that we started this section with. So let's take that back to our problem. Oh, we're over a couple pages. So the derivative of 4x would just be 4x times ln of 4. All right, so we're almost there. We just need to compute the derivative here. So derivative of 3 plus 16x cubed. Well, derivative of constant 3 is just 0, so we just have 0 there, plus derivative of 16 times x cubed. Well, we have 16, that constant, times, now we're going to take the derivative of x cubed, so that 3 comes down, times x to the 3 minus 1 is 2. So we just get 16 times 3, which we could compute, which is just 42x squared. And note, I did pause the recording to compute 16 times 3. I'm not that quick. All right, so now we're almost ready. Let's just combine these, what we learned together. So here, my derivative starts with 3 plus 16x cubed times that first derivative we just computed was 4x cubed plus 4 to the x ln of 4 minus, and notice I kept that whole derivative that we just computed inside parentheses. It's really important to use a lot of parentheses just to make sure your work is all clean and all of the products that you want to compute are together. All right, so now times x to the 4 plus 4x squared times this derivative we just computed, which was just 42x squared. all over 3 plus 16 x cubed squared. So now at this point, you could multiply things out, FOIL this out a lot, FOIL out here, combine and simplify. But for us, what we're concerned about is using and practicing that quotient rule, that derivative of quotient. So for us, on our purposes, this is a fine answer to stop with.